On March 31st, 2026, at 2 a.m. Pacific, the first public leak thread hit Hacker News, and the story took off from there. The package version was 2.1.88. Inside it sat cli.js.map, a 59.8 megabyte source map that should never ship to production. Security researcher Cheofan Shou pulled the package, ran a routine reconstruction, and immediately recovered about 1,900 TypeScript files. Then the scope became clear. Roughly 512,000 lines, enough to expose architecture, safeguards, and unreleased product hints. By that evening Pacific time, public mirrors were exploding, and one repository raced past 1,100 stars with more than 41,000 forks. Quick checkpoint: why does one extra file matter this much? Before minification, code reads like plain language: handle login, show error, and authenticate user. After minification, meaning collapses into tiny symbols like A, B, C, and D. A source map reconnects those symbols back to real names, real files, and real line numbers. So if the map ships publicly, outsiders can walk backward from bundle to blueprint. Now watch how fast the timeline moved once the map was spotted. March 30th. Pacific evening, version 2.188 is published with the map included. March 31st. Pacific morning, Cheofan Shou confirms reconstruction and shares the finding. By midday, Reddit, X, and Hacker News are amplifying it across the developer world. By afternoon, mirrored repos appear and forking accelerates at a pace you almost never see. By evening, Anthropic responds publicly and calls it a packaging issue caused by human error. Release to global analysis in under 24 hours. That speed is the lesson. The cause was not a zero-day exploit. It was release hygiene. Bun-generated maps, exclusion rules missed one artifact, and NPM published everything as is. Anthropic said no customer credentials or customer data were exposed in this incident. But trust still took a hit because the internal implementation became readable overnight. That is why build pipelines deserve the same rigor as runtime security.
Once reconstructed, the code looked less like a script and more like a layered platform.
At the edge, roughly 40 built-in tools handle file ops, shell execution, web fetches, and IDE tasks under permission gates. Underneath, a very large base tool layer defines validation rules and execution contracts across the whole tool surface. Then requests flow into a separate query engine that manages model calls, streaming, caching, and orchestration. That core is wired to JWT-backed bridges, so VS Code and JetBrains integrations can talk securely. On top, the React plus Inc terminal experience turns those internals into a usable command line interface. And when one agent is not enough, swarm coordination fans work out across multiple Claude instances in parallel. Security-wise, the leak revealed deliberate anti-distillation controls, including decoy tool injection and summarized connector text. It also exposed Undercover mode, a path intended to remove obvious AI authorship markers in some external commits. For user sentiment, the system even includes lightweight regex triggers for frustration language. And across the codebase, dozens of feature flags expose experiments that were never meant to be public. Put together, this is a case study in how technical controls, governance policy, and product strategy collide. Another notable piece is native client attestation, used to prove requests come from the official binary path. Around that path, shell safeguards add defensive checks against tricky expansion and command injection edge cases. At the same time, public CVE history shows trust boundaries in agent tooling still need constant hardening. Code quality signals matter too. Large monolithic files and retry inefficiencies can silently burn reliability and cost. So the picture is mixed: strong security intent, real engineering depth, and clear maintainability debt. Community reaction split into 4 conversations happening at once. Security teams asked, what did this reveal about permission models and execution boundaries? Developers asked, what can we learn from the architecture and tooling patterns? Business leaders asked, how much roadmap intelligence did competitors just get for free? And ethicists asked, should AI-assisted open-source contributions be explicitly disclosed? Beyond the headlines, the leak exposed a classic engineering tension: velocity versus maintainability. One side is structure risk, like very large files, that concentrate too much behavior in one place. The other side is operational risk, where small retry or compaction failures can multiply into real API spend. Feature flags were the strategic flashpoint, because names alone can telegraph where a product is heading. Kairos appears to point toward an always-on autonomous workflow, with daemon cycles and memory distillation. Buddy looks like a companion-style path, likely more experimental than enterprise-critical. Ultraplan suggests deeper planning and decomposition for complex multi-step execution. Capybara appears as a model codename, adding another hint about forward platform direction. And these examples were just a slice of a much larger flag surface controlling internal rollouts. If you ship packages to NPM, the practical playbook is simple: inspect artifacts, block source maps, and verify publish rules every release. If you build AI tools, treat permission enforcement and shell hardening as core product work, not optional extras. If you lead teams, define your disclosure stance early for anti-distillation behavior in AI authorship policy. Takeaway 1, source maps are blueprint files, so packaging mistakes are security events. Takeaway 2, permission systems are foundational infrastructure, not polish. Takeaway 3, anti-distillation defenses must assume adversaries can proxy, strip, and replay traffic. Takeaway 4, hidden authorship behavior needs explicit governance, not quiet defaults. Takeaway 5, once mirrors spread, rollback is impossible. Prevention is cheaper than cleanup. Every claim here ties back to public references, so you can verify the details yourself. Use multiple sources, compare timelines, and separate confirmed facts from speculation. The pattern to remember is simple: advanced systems still fail on ordinary release discipline. If you want more post-mortems like this, stay with the series, and we will keep turning incidents into engineering checklists.